Okay.
Hello, whoever's watching.
Yeah, for all those of you watching at home, hello. We are continuing the notes on integration by parts.
And those random guys who
Yeah.
watch this on YouTube.
random guys from,
Can
if I won't say
somebody-
anything, from where?
Can somebody refresh my memory on the formula for integration by parts?
Or was it like the integral from u, or u dv
The integral of u dv,
equals uv minus integral v du?
yeah. You notice the two integrals are the opposite order of each other. u dv versus v du.
Couldn't use different letters, like so close looking.
Yeah, they do like
That's, yeah.
The reason integration by parts works is that they're gambling on the idea that if, and both of these have to do with like trying to integrate a product rule thing. It's like a function times a function that just doesn't simplify. And if one order doesn't work, they're gambling that the other order will. So we'll see what happens. Let's try this. What do you think? Now, in order to do this, you have to pick two parts that are multiplied. One of them has to be the regular function u,
One has to be
and the other
dx.
one has to be a derivative, dv. And there's two different ways you could do it. I mean, the thing that comes last does not necessarily have to be dv. dv might be x dx. And the regular function might be ln of x that just got moved out of order. Does that make sense? So attach the dx to the derivative part of the dv, but it could be either or, whichever one you think is best. Does anybody remember the rule of thumb by which we choose?
If it gets uglier, then you don't use that.
Right. If it gets uglier, then you use the other one. So let's do a little experiment. Let's try u and dv. What would be one choice?
X.
I'm going to try them both. So u equals x, and then dv is equal to
L
ln of x dx. Does that make sense? So versus, what's the other way around?
ln x is u, and then dv is x dx.
X dx. So those are the two possibilities. There is actually another one, but I'll show you that later. Try this first one. How would you test it out to see if it actually works?
You would plug it in the formula?
Yeah, what do you calculate based on this?
Oh, du.
du. Find du and tell me what it is.
dx.
That's looking good.
Yeah.
Now try v.
So is that
Du.
1 over, oh wait, I don't know.
That's the derivative of
Yeah,
ln of
I
x.
don't know.
What's the antiderivative of ln of x? We've never run into it before.
Oh, wow, that's pretty good.
Absolutely no clue. So that's actually a big hint. If you ran into something that's a complete brick wall, usually don't run into it again. That's a good life lesson too. Try the other way. What's du?
Oh, that's nice, yeah, 1 over x.
1 over x
Yeah.
dx. What's this thing? You'll have to do the
1/2,
antiderivative.
wait, 1/2
Uh-huh.
x. The 1/2, wait, no, it's
X squared. And that's pretty much it. Now, it looks like this is getting uglier, but this got a heck of a lot easier, and it looks like this, at least it's possible. So I'm gambling on this one. Let's try it. So it's basically the integral of something times something. So we're doing, what's u and what's dv?
U is the ln of x,
ln of x. And then the other one is,
x or
X dx.
x dx, yeah.
okay, is equal to uv minus the integral of v du. So fill in the relevant parts.
So it's ln of x, and then
This I'm just going to scratch off, so it's not a distraction.
that's ln of x times x.
Yeah, this is regular.
Oh no,
So the integral of u
it's
dv
ln of x times dx.
is u v, v
Okay.
du. So use this chart and fill in this
Oh,
stuff.
yeah, ln of x is 1/2 x squared.
ln of x times 1/2 x squared. Good. What goes here?
1/2 x.
Good. 1/2 x squared times.
1 over x dx.
And this actually simplifies a little bit. at this, I put the 1/2 on front here too. So 1/2 x squared ln of x. I don't really care what order you do those in. The reason I don't do this, 1/2 ln of x squared, it kind of looks like the natural log of x cubed.
Yeah.
Which looks a little confusing. This is kind of the best way to write it. This is gonna be minus 1/2 times the integral of what?
Of x, dx.
X dx. That's doable. That integral is doable. So this thing you don't even have to touch. We're not taking the antiderivative of this, we're just done. So 1/2 x squared ln of x minus 1/2 times what? And this one should be relatively generic. We actually did it already. We're just doing it again. What's the antiderivative of x?
Oh,
1/2 x squared. And then put a plus c at the end. What's your final answer?
Oh, it's the it's 1/2 x squared ln of x
Uh-huh.
minus 1/4 x squared
Yep.
plus,
And you're done.
painful.
you know it.
Oh, it's okay, once you get used to it. It is sort of kind of. Thank you, sir, may I have another category? You've heard that cultural reference?
What?
Like in the military, there's a,
Right.
not only are you gonna do 25 push-ups, you're gonna like it, and you're gonna beg me for more.
Oh, yeah.
Get on down there, do 25. Thank you, sir, may I have another? Absolutely, 25 more. Thank you, sir, may I have another? Absolutely, 25. Yeah,
Wow.
that's the proof.
Yeah, it's
That's the cultural
it's
reference
like Pete,
behind it.
Pete and repeat.
Thank you, sir, may I have another?
Wow.
Anyway, you know, there's those kids. Questions?
Nope.
Okay. I smell that corner, but whatever. In, like, in that corner. I don't know, there's an electronic something or other.
There's a lot of wires and tech over there.
Yeah, I know.
What's
So
the
something's
Wi-Fi?
like,
Yeah, that's a little.
when we hear something sizzling over there, like,
Right. So, any questions on this? Does that kind of make sense?
Yeah.
Alright. Let's try something else. This, I'm actually gonna give you a category for this in your notes.
ooh,
I know. Normally I just do discovery method.
I don't like cats.
Repeated integration by parts. There was a problem yesterday where it looked like we would have to do the integration by parts again and again and again. But that was just getting worse and worse and worse, and it was gonna go forever, so which is not practical. That being said, what about this? Excuse me. The integral of x squared e to the x dx. Isn't as exciting looking one. Now, if we ran into this in the wild, so to speak, does everybody see that it looks like a product rule?
Mm-hmm.
It's a function times a function. Integration by parts is designed for things like that. So, you know, because we can't substitute anything directly. I mean, if you try, you do u is equal to e to the x, no. U is equal to x, that does nothing. U is equal to x squared, just a regular substitution doesn't work. Maybe integration by parts will work. Any recommendations of what to choose for what?
We're just guessing, right?
Correct.
So like x squared.
With each new guess, we're going to get a little bit better at guessing. But look ahead and tell me if this is, like, what are you going to do to the u? What are you going to find
Take the
immediately?
derivative.
The derivative of it, the du.
Oh, so that's probably ex.
That's probably, in other words, would the derivative be Easier or harder?
Harder, like 1/3 x cubed.
Way easier.
Oh no, yeah,
It's
2x.
easier, way
Like 2x,
easier.
yeah.
Yeah, easier.
Yeah.
Would the antiderivative be easier or harder?
Harder, harder.
Harder, it'd be 1/3 x cubed. What's the derivative of e to the x?
It's the same thing,
E to the x. What's the antiderivative?
same thing.
E to the x. It doesn't make any difference.
Okay.
So, which is totally nice. So which one would you choose
Wait.
for u?
X squared.
If this one makes no difference.
There's one that went to
the other,
2x, so the x squared.
Make this one easier. Yeah, x squared looks like a good choice. And we'll do e to the x dx here. So what's du?
2x.
2x dx. And then what's v?
E
E to the x. There will be a plus c there, but we stick that at the end anyway. Let's try it. This is u. This is dv. It actually came in the right order this time. Do the integration by parts. What's the formula? The second half of the
That's
formula?
uv
uv.
minus integral of v du.
v du. Okay. So tell me what that is. What is u?
U is x squared.
Yeah, and then u is x squared. And then v is what?
E to the x.
E to the x. That's done. You'll never have to do that again. You're no integration, just you're done. Here is what?
E to the x.
E to the x times what?
2x dx.
Times 2x
dx.
dx. Let me rewrite this. Equals, it's kind of a toss-up as to what you put first, but I'll just do x squared. E to the x. You notice the first part is pretty much identical to what you started with? That happens a lot when you have e to the x. Minus the integral of, I'm going to move this in front, 2x e to the x dx, and I'm going to pull the 2 in front. Look at that integral. X e to the x dx. How would you take that integral?
To do repeated integration. by parts.
Another integration by parts. Now, there is good news. Has the integral gotten better or worse?
Better.
Better. One more shot will probably kill it.
Yep.
To give you an idea, if this had been x cubed, you would have had to do integration by parts 3 times in a row,
U.
which does happen
Well, it's probably a pattern, so it's probably x squared u dx, then minus
sometimes. The
x.
x squared, then x, then, yeah, etc. Let's go ahead and do this. So a brand new, pretend this stuff no longer exists. Let's just start the problem over. U
U is
dv.
U is x.
U is x, dv is e to the x dx. Good. So what's du?
dx.
Just plain old dx. That's looking good.
Yeah.
And then v is
dx.
e to the x
dx.
dx. Oh yeah, yeah. Oh, not dx. Just e to the x. So let's do this. I'll leave this part out here. So x squared to the x, that won't change. Minus this thing. I'm going to put big brackets around it. It's going to be uv minus the integral of v
Do we pull the 2 out of it? The 2 out.
Minus the integral of v
Yes.
du. Oh yes, thank you. The 2 is way in front. So what's u?
X.
X. What's v?
Ex dx.
Dx. Okay? So what's this?
Minus, and then e dx.
E to the x
dx.
dx. That's finally a normal integral. What's the integral of e to the x dx?
Yeah, that's equal to that.
It's e to the x. So here's the thing from beginning to end. Oh, by the way, you're going to have to distribute the 2. So there'll be x squared e to the x minus 2x e to the x minus this hits with the 2 and this hits with the 2. Ever see where the 2 came from?
Yeah.
Okay. And then 2 to the x plus,
Plus e.
you're done.
Wow.
Those are the more annoying ones
Yeah.
that we have to do it repeatedly. I have encountered problems. If we have time, I'll show you some next week there is a trick to doing, like, there are some problems where you have to do integration by parts like 4 or 5 times in a row.
So it's like the bigger the exponent, the more times you have to do it, kind of like the bigger.
Exactly. Right. And there is a trick to it. There is, if you have like 4 or 5 or 6 or 10, God forbid, 10 times in a row, there's a certain, it's something called the table method, where you can just stop and predict. There's a certain pattern that shows up here. Because you notice the original one is carbon copied, and then the second version is just carbon copied. So there's a certain pattern you can cut through the chase and do a lot faster than clunk, 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 clunk. Again, if we have time, I'll show you. If not, not a big loss. Questions? Alrighty. I want to give you just a taste of something new, and then I'll give you the worksheet for today. Well, not for Monday, it's on integration by parts. This new topic is not going to be on the homework yet. It will be on next week somewhere. But it's actually one of the more fascinating topics. Does anybody happen to remember what this means? What is that creature?
The inverse of sine.
It's the inverse sine. Of x. For example, think way back to what is the sine of 30 degrees? Think of it in a circle. Or
That is
36
the
degree triangle.
radical 2 over 2.
That's for 45.
Oh, then it's radical 2? No, it's, shoot, what is it?
I don't remember.
Okay.
Is it radical 3?
Does everyone remember the 30, 60, 90 triangle?
Oh, yeah.
Go ahead and draw one. This, remember the sides? What are the sides of 30, 60, 90? What's the smallest side?
It's like
One.
1, 2,
Then radical 2.
radical 3.
Radical 3,
So
yeah.
1, 2, radical 3. Radical 3 is the medium side, by the way. 2 is the biggest. Using this,
So it's radical 3 over 2. Isn't it?
close.
Oh, 2 over radical 3.
Wait, is it?
What?
Two-
2 radical 3
No, no,
over
no.
3.
Hey, 1 over 2.
It's 1 over 2.
Yes.
Oh, it's 1 half, right?
All that, good, yeah. What is the definition of sine? So
It's
if
up,
it's
down.
Yes.
Opposite
Opposite
over
over
hypotenuse. Jump on the 30-degree angle.
Yeah, one half.
1 half.
1 half.
Dang it. Every guess is
No,
sine.
no,
So
no.
this there is every possible fraction we guessed. So that was really impressive.
Good job.
Now, but the reason
Sounds
I'm
right.
bringing that up,
Who my teacher?
can anybody guess what this would be?
30.
It's 30 degrees.
Yeah.
What happened there?
Inverse.
It's inverse. All an inverse is, when you think inverse, think the word reverse. It goes in reverse. It undoes what the original one does. It goes backwards. So if I have f of 3 is equal to 7, and I don't even tell you what the function is, I'm gonna say f of x is, who knows?
If you get integration of
Can anybody tell me the
Inverse
inverse
of
function of 7?
3.
It's gotta be 3. Does that make sense? That's how inverse functions work. Now, here comes the exciting part. Ooh, did everybody get this?
Yeah, I got it.
Okay,
Yeah,
good.
Oh yeah, whoops. Sorry, Ella.
Oh, yeah, I'll never, yeah, they can rewind the video.
Oh yeah.
Good job.
We could rewind it too if you want to see it.
Just click the
That's
pause
true.
button.
Yeah, just don't rewind it now. That would make bad things happen.
I didn't know how it worked.
So, try this. First of all, can somebody tell me the derivative of sine x? Just plain old. So no trick question.
Oh, it's the cosine of x.
It's cosine of x. Now, if I don't have the prime notation, what would I have to put at the end?
d plus e or dx.
Yeah, plus here would be answer derivative.
Right.
Everybody over there?
Mm-hmm.
Sure.
Curveball time. What's the derivative of the inverse sine of x? Guess what everybody wants to say?
Inverse sine of
Inverse
cosine?
cosine. Everybody would say, wouldn't that be awesome? Wouldn't that be lovely? Yeah, it would. It isn't. It's actually quite a bit more exotic. Let me show you what I mean. There's actually a life lesson involved in this. There are loads of life lessons involved in math.
Is there a story too?
Well, maybe.
Maybe about
I'll have to think of this.
someone named Murgatroyd or something?
No, not to my knowledge.
Or what's it called? Right.
There's a good life lesson. One of the best ways to progress is to admit that you don't know.
Yes, that's good.
It's like one of the things they teach it, it's like having a teaching mentor. They were saying like, okay, if you're in the middle of class and you're first year teacher and somebody asks you a question you do not know the answer to, don't make up an answer.
Yep.
Just say you don't know, and then I'll look it up, and then go ahead and look it up, and then get the answer to them tomorrow. That's what everybody should do. Unless they're a complete lying scumbag, in which then I get it. But what is the derivative of inverse sine? I have absolutely no idea.
Liar.
Liar. But here's what I'm going to do. In math, if I don't know something, I admit it. Here's what that means. What is the inverse sine of x? No clue. I'm calling it an unknown.
Yeah.
A variable.
Oh, Lordy.
That's the math way of saying I don't know.
Yep.
And it comes in handy too.
Typical.
Now, somebody's asking
We don't
for
know, let's just make up a variable for it.
what's the derivative of y? Well, that's our original problem. I still don't know. Because it's the derivative of inverse sine. Somebody came along and got really sneaky on us.
How sneaky.
And the tension has been wound up. Oh my goodness, what is it? What is it? I have to drag you out 4 minutes for a pre-calc review. This is a trig type of problem. Oh, glory to God. And we do have the video recording, so, and I'll try my best to post it during the day. Pre-calc, I was posting video for, they said, can you please go over these last 4 problems or something, and sure, I'll video them. I finished it at like 9 at night, so I'm not sure how useful it was to them to the best of today. So, oops. Unless they all sit up till 11 watching the silly video.
Wouldn't be surprised.
So, mea culpa.
Freak out.
Does anybody happen to remember from pre-calc running into a beast like this?
No.
It looks weird.
Kind of.
The sine of the inverse cosine of 3/7. This is what I affectionately call a forward backward problem. Quote unquote. A forward backward problem, you'll notice there's a regular sine, a regular trig function, followed by an inverse trig function. This goes forward, this goes backward. That's why it's called a forward backward problem. How do you do a forward backward problem? The cure for this, quote unquote, step 1, draw a trig shape. Usually a right triangle.
Yeah, we did not do this.
Place the numbers in the appropriate spots. outside function. Do you ever remember that if you have parentheses, inside parentheses, what do you do first? The inside parentheses first. That's exactly what we're going to do. We're going to do the 3/7 first, which we can't do much. Then we're going to do the inverse cosine of it. Then we're going to do the sine. We're just following the normal order of operations. So what do I mean by this? Draw a trig shape, usually a right triangle. By the way, quick question. I had this as an example. I erased it. The sine of 30 degrees is equal to 1/2. And then the inverse sine of 1/2 is what? 30 degrees. Because an inverse, it just means go backwards, reverse. So when you take the trig function of an angle, there's a symbol for angle, but you get out a fraction. So guess what you plug into an inverse trig function?
Fraction.
You plug in a fraction and get out a what?
Get out of the number.
Angle.
An angle.
Angle, yeah.
Does that make sense?
Hopefully. What else would you get out?
Right. Now, we're doing the inner layer first, right? The inverse cosine of 3/7, what should that give us as an answer? Don't worry about the sign now.
Angle.
It should give us an angle, right? This should give us an angle theta. Draw a right triangle. And we usually put theta somewhere. You can put wherever you want. Don't put it here. We need the right triangle. But just put theta here. Draw a trig shape, use your right triangle. I should say put theta in a convenient spot. It really doesn't matter if it's on the left or on top. Just don't put it here. If this is true, can somebody put the 3 and the 7 where they belong? If this really came from the cosine, where do the 3 and the 7 belong?
7 is the hypotenuse and the 3 is the leg on the,
Yeah.
the base.
They're basically saying the
Base.
cosine of theta is equal to 3/7. So what is it again? I'm sorry?
7 is the hypotenuse, right?
7 is hypotenuse.
And 3 is the base. Yeah, that way.
Yeah. Adjacent over hypotenuse. Ta-da.
Da.
You're actually half done with the problem. Can we find this missing side?
Yeah.
Oh, people who remember geometry?
Yeah, 3 squared plus
49, so radical 40.
Not plus, but. Oh, I see what you're doing. So 3 squared plus b squared equals 7 squared. So if you want to find this side, you'll have to subtract. So it's b squared equals 7 squared minus 3 squared. What is that? 49 minus 9 is 40.
Yep.
So b squared is 40. Somebody do that for me?
Radical 40.
It's radical 40.
Which is,
Is there a perfect square in there?
yeah, 4.
Yeah, right.
So
4 times radical.
2 radical
10.
20. But radical is
2 radical.
Oh, yeah.
2 radical 10.
Yeah.
So the sign here is 2 radical 10.
4 or something like that.
Everybody still with me? It seems like I'm doing random stuff here.
Yeah.
So step 1 is draw a trig shape and put theta somewhere. Place the numbers in the appropriate spots and calculate any missing numbers. Do the outside function. It's stunningly easy at this point. What are they asking for?
Inverse cosine.
Actually, we already did
Sine,
that.
sine, yeah.
They're asking for sine. They basically want the sine of theta.
So 2 radical 10 over 7.
You're done.
What? Wow. It's actually kind of cool.
The sine of the inverse cosine of this is 2 radical 10 over 7. Let me try another one just to make sure everybody's got that down. Yeah, I've got to keep this.
Wow,
up.
that's actually really cool.
This neatly thing is coming up.
Just do everything with it.
Try this. The tangent of the inverse sine of 4 over 5. How would you do a problem like that? What's the very first step? It's called the forward-backward problem. You've got a forward trig function followed by a backward trig function. What's step 1?
Draw the
Draw a triangle.
thing.
Yeah, draw a trig shape, but 95% of the time, it's a right triangle. The other 5% of the time you'd be drawing what's called a unit circle. But just a second. Right triangle. Okay? There's the right triangle.
Yeah, and you place appropriate numbers, so.
Yeah, and what should I put in?
4 on the opposite side. Or you can do theta on the
Yeah,
bottom.
put theta wherever you want. You can put it wherever you want. Where would you put the 4 and the 5 so that this makes sense?
So opposite, so 4 on that side.
4 is opposite,
Over adjacent.
5 is hypotenuse.
Wait.
Did anybody tell me what this is?
Oh, you mean the
Three.
side
Oh,
tangent.
you remember this from way back when?
3, 4,
This is a
5.
common triangle. It's 3, 4, 5. I didn't draw it very well. That's because I'm a bad
Would you
artist,
mean the
so.
sine of it?
Hey, the 4 looks shorter than the 3. I know, because I'm a bad artist. So, whatever. But here's our missing side. Find the tangent of this angle.
4 over 3.
You're done.
Thanks.
Isn't that neat? You didn't have to do a single calculation of a sine or a well, but one tangent. It's very quick. It's
Yeah.
surprisingly quick for something that looks so complicated.
Yeah.
Normally, when you do an inverse sine or cosine or whatever, you get this horrible. You know,
I feel like it should be different for the sine, because it's sine of -1. That you should do it differently.
Yeah.
Not just a normal way.
How we did this, drawing the shape did it.
Huh.
It just sort of did it automatically.
Couldn't we do the same thing with regular sine though?
With regular, if you have a tangent of regular sine?
Yeah.
But the thing with sine is we're getting
Well,
fraction.
regular sine, they wouldn't give you a fraction, they would give you
an
theta.
angle, right?
And you wouldn't know,
Oh, I
and we
see.
wouldn't know what to do with it.
Oh yeah. Got it. Never mind.
So this is going backward to find the triangle, and then going forward to find the new tree function. Why did I bring all that up?
Good question.
Well, I'm glad you asked. The mysterious people in the past who were playing with this knew about forward-backward problems. Watch what they're going to do. First of all, this first part has nothing to do with this, but it's totally sneaky. Our question at the beginning of this was, how do you take the derivative of inverse sine? I have no idea. I barely know what inverse sine is. I know it's the backwards version of sine. So I said, what is it equal to? I don't know. The math way of saying I don't know is call it a variable. It's much more dignified and it's much less embarrassing. They say, so, what is your main topic of tonight? And rather than saying, I don't know, you just say, my main topic is variable y. And everyone goes, ooh. Instead of saying, wow, what an idiot. He doesn't know what he's talking about. It has a much better effect. Watch this. Inverse sine of x, I'm just going to recopy this for a second, equals y. Is there a way to get rid of an inverse function? Yeah.
We just did it.
By taking the regular function,
Oh.
as long as you do to both sides. Watch this. Totally select.
So it's a cosine of
Boom.
y.
X equals sine of y. We learned a couple of weeks ago, this is with logarithmic differentiation. If you took the log of both sides, the derivative is still exactly the same, which is almost magical. So you'd expect it to get pounded to the pulp. But you can do anything you want to both sides and the derivative doesn't care. Including take the sine of both sides.
Wow.
If I take the derivative of this, I should get the exact same answer as this.
So cosine of
Let's try it. Let's take the derivative. Now you do have to leave the dx's and dy's lying around. So what's this?
dx.
Yeah, 1 dx or dx equals, what's the derivative of this?
Cosine of y dx. Or dy.
Cosine of y
dy.
dy. Now, can you get dy by itself?
Divided by cosine of y.
Yeah, divide both sides by cosine of y. Actually, it's even better. Can you get dy over dx? That way I won't have to trip over the x.
Yeah.
So these cancel.
dy over dx.
And then just divide both sides by dx.
Yeah.
And these cancel. So I have 1 over cosine of y is equal to dy over dx. Believe it or not, that's kind of done. There's just one little thing I'd ask you to do. Now, if this is a derivative, yay, the original function had x in it. Can you replace that y?
Sine of negative one of x.
Yeah.
Put it back in. We've done that before. Cosine of the inverse sine of x. There's a derivative. Does this look familiar? Oh, people who watched the other side of the board 10 minutes ago.
Oh, yeah.
Forward, backward problem.
Oh, yeah. Yeah.
Forward, backward problems only work with fractions, though. You're absolutely right.
Oh, my word.
This is the time I really, really lament having a mask on.
So smart.
Because you can't see me just break into this huge, ridiculous grin.
Yeah, beware when a math machine grades.
So, let me get this out of the way. Tell me how to do cosine of inverse sine of x over 1. What's step 1? Draw a triangle. Right triangle, put theta where it be 1. Where would I put the x and the 1 so that makes sense?
X would be down.
So we're going to just ignore that. So opposite? Hypotenuse is 1. Find this missing side for me. Pythagorean theorem, people.
Radical X? No.
Anybody know there's a shortcut to this, by the way? I can show it to you.
What?
There's a shortcut for finding a missing side of a right triangle.
What's 1 minus X? Radical 1 minus X.
Let's just say that, like, this is, I'm just going to make this up. This is like 7, this is like 2, and this is like x.
Yeah.
Am I going to have to add or subtract to get this?
Subtract.
Subtract, because it's the small on the small side. This is going to be radical 7 squared minus 2 squared.
Yeah.
It's the Pythagorean theorem turned inside out. So here, it's going to be radical 1 squared minus x squared.
Yeah.
There's a little simpler you can write it. 1 minus x squared. Find the cosine.
Radical 1 minus X squared over X.
Radical 1 minus x squared over
1.
1. Better known as.
Radical 1 minus X squared.
Put that down here. This is a 1 over what?
1 over 1. Radical 1 minus X squared.
You are looking at the derivative of inverse sine. No one would have expected a beast like this. For 2 reasons. Number 1, where'd the radical come from? Number 2, why aren't there any trig functions in this thing? It's like, we took a derivative, derivative of sine is cosine, derivative of cosine is negative sine, derivative of tangent is secant squared. Trig begets trig begets trig. Why are there no trig functions in my answer? I don't know. So,
So you went from 1 over cosine of y, how did you get to the cosine?
of this?
Yeah.
Oh, because I knew from the very beginning that y was equal to this.
Oh.
I plugged this in.
Oh, okay,
No problem. Now, guess that? Again, this trick is not going to be for tonight's homework, it's going to be for next week, when we start taking the derivative of inverse trig functions. On Monday, I'm going to walk you through, I'll do this again, just for, the leader shows up. And I'm sure you'll be watching the video, but we'll do it again, just to make sure everybody's fresh. Then I'll walk you through the derivative of the other 5 trig functions, inverse trig functions. By the time we're done with Monday, you'll see unless something scrunches the schedule, of course, we'll go through the derivative of inverse sine, inverse cosine, inverse tangent, inverse cosecant, inverse secant, inverse cotangent. All 6 of them we'll have nailed. And by the end of next week, which is Holy Week, wow, we'll have them mastered. And they're relatively friendly. This, even though it's weird, it's not that big, for one thing. It's not that hard to memorize. And there are repeating patterns that will show up in these things. That will help. Yeah.
We're gonna derive the answer, and then that will be the, you just plug in
Right.
cosine for all.
So in other words, if I were to say on the test, what's the derivative of inverse sine of x?
You would use that.
It's this.
Okay.
Could you just memorize it? Absolutely. That's actually faster. If you get stuck, could you derive the formula again using forward-backward problem? Yeah, you could. It takes like 10 minutes or 5 minutes or something like that. Better than getting the problem wrong, usually. But yeah, I will also give you a chart of all 6. And there are patterns to the final formulas which make it easier to memorize, which I'll talk about next week. Okay, pardon me for a moment. Let me pick up the worksheet. Be right back.
Hello, do you know where Lou is?
No.
No.
I think he was over there when we
Oh, yeah.
Oh, okay. Oh, I see, I see.
Hey, Ella, have you seen the village before?
No.
Okay.
I've always wanted to see it.
It's really, it's like The Sixth Sense, a lot like it.
Is it scary?
It's thrillery. It's not totally scary, but there's things that are scary in it. Just the way they, like music and all that stuff. And there's
It would have sense except the Tony cartridge was empty.
Oh, nice.
Yeah.
No homework.
the premise is that they live in a village and they don't go in the woods because there's monsters there.
That's good. I've seen the first
That's
5 minutes. I've seen the first 5 minutes of it. And they're nice. Look at it. Like,
Yeah, the kids like make like kids like
Yeah.
kind of like dare each other to go stand out
yeah,
there.
yeah. That's it.
Oh, I know, and for reference, the tonight's homework is on integration by parts, not on this stuff.
Right. Right.
Okay. See if it's actually good.
It's the butt.
The
It's
butt.
the butt.
Barley. Blah. Yeah.
Blah.
My car, my parents actually.
It worked, and they're nice and toasty warm.
Oh yeah. I like those.
Whoops, toasty two of them.
Oh, you gave us the. Oh, that's the first one.
Just for one of them.
Yeah.
No problem.
How fast are you?
So, the worksheet I just handed out, number 1, just to be Mr. Nice Guy. Number 1, if they gave you the U and the DB to use, just for, that's only one, so don't get used to it. But, the other ones are on your own. Some of them are going to be repeating. Oh yes, I do need to show you one last example. It's very quick, but the worksheet is trying to fool you. This was a stumper for me for quite a while. I had to ask somebody for the answer. And the answer was, one of those, I call it mathematical evil. There's a difference between mathematical evil and moral evil. Moral evil is you gotta go to confession and, save your soul. Math evil is just fun. It's like a really, really clever way to do something where it's, oh, come on, that's just wrong. But, wow, that's neat. This. Remember we ran into this?
Yeah.
And we had absolutely no idea how to get the antiderivative of L. The derivative is 1 over x. The antiderivative is who knows. This is an integration by parts problem.
Say what?
You say, wait a minute, integration by parts is only for products. It's like something times something. I said, yes, you're right. There's only one part. Really? There are actually 2.
Is it?
dx is its own part. Basically 1 dx.
What?
Try it. Tell me what you think would be u and dv.
Well, taking the derivative of dx, what even is that?
The derivative of dx, that's a good point.
So,
So versus, let's try the other way around. If you had u is equal to dx, what's du? Yeah, there is actually an answer to that, but we haven't covered that. That's going to be like 3 weeks from now. But for now, we have no clue. That's a good hint that probably the other way around will work. So what's u? And by the way, this would be even worse. So what's V?
1 over X.
It's the answer to the original
Oh,
problem.
yeah.
So if I knew how to do this, I wouldn't need it, because it would be the original problem. So I think, so other than being a complete disaster area, that was pretty good. Try this. ln of x. Try this. What's du? 1 over x dx. And what's this thing? X. Now that's nice. Surprisingly nice for a really stubborn problem. So this is the integral of u dv. Give me the integration by parts formula.
The integral of, what
Yeah.
was that?
Of u dv is equal to
UV.
uv
Will be
minus the integral of
DD.
v du, the other way around. So what's u? ln of x. What's v?
X.
X. You do not have to integrate that, it's done. Minus the integral of what? X times 1 over x dx. This. Actually, you don't.
Oh, wait, you can cancel that.
Cancel. What's the antiderivative of dx?
You don't know.
X.
Oh, X, yeah. Oh, yeah.
1 dx, it becomes x. This is x ln of x minus x plus c, and you're done. Isn't that evil? There is a problem or two on the worksheet that looks a lot like that.
John, how do we find V?
Problem number 6.
Yeah, so it's, you have to go take the antiderivative of
Yeah.
cosecant squared.
And by the way, number
What is
7,
that?
so 6 and a 7, number 7 I would suggest doing a regular substitution first.
Wait, is that like tangent or something?
It might get a little
Oh,
frustrating.
yeah. No, it's cotangent.
Everybody?
Yeah.
Sometimes you can also use log rules to help. Now be careful. Number 7, can you pull the square out front? No. Only if the x is squared can you do that. So be careful. If there was ln of x like this, but any log rule,
Oh, I know what you mean, yeah.
this can pull out in front, but ln of x quantity squared, don't do that. Make sense? All right, go to it. Enjoy. Call me up for good stuff. I think we can deactivate the video. See you later, Ella. And see you later, Ella, the earlier Ella from the